students, so in the previous class we had solved few IES problems and GATE problems. So today also we'll solve the same few years back GATE problems, and we'll try to focus on two concepts or the two formulas which I had derived for you in the previous classes. This is nothing but SE is equals to WGS and gamma T is equals to GS plus SE upon 1 plus E gamma W. So here we can also replace SE by WGS, and lots of questions are based on that particular thing. So your basic aim should be to find out the quantity which is not given. Okay, so you have to manipulate between only these two formulas. These are more than enough for solving any problem in soil mechanics from the first chapter. Okay, based on simple terms which I had denoted in the previous class. Okay, so let's pick up now to the next one. The next question which I'll be taking will be from previous years. Okay students, the next question is from GATE 2004. The question is, a saturated soil mass has total density is equal to 22 kilonewton per meter cube and water content of 10%. The bulk density and dry density of this soil are, option A is 12 kilonewton per meter cube and 20 kilonewton per meter cube. Option B is 22 kilonewton per meter cube and 20 kilonewton per meter cube. Option C is 19.8 kilonewton per meter cube and 19.8 kilonewton per meter cube. And option D is 23.2 and 19.8 kilonewton per meter cube. So this is a very simple question based on a simple formula, and the question says that the total density is 22. So total density is nothing but bulk density, which I have already told you in the previous class. What is total density? It is nothing but the bulk density. So gamma T is directly given as equal to 22 kilonewton per meter cube. Moreover, the water content W is given as 10%. So the option is very simple. That first option B is obviously directly correct. But let's try to find out the gamma D value as well. I had given you a formula that gamma D is equals to gamma T upon 1 plus W. That is equals to 22 upon 1.1. So that is giving me 20. The answer is coming out to be 20 kilonewton per meter cube. Okay, so if you don't remember this formula also, then also I think so you can very well solve it, because we know that water content is nothing but equal to W upon WS, and gamma T is nothing but equal to capital W upon V, and gamma D is equals to WS upon V. So from here we can manipulate these two terms, and we can very well, if we want to find out W, so we'll add 1 both sides. So because this WW will become plus WS will become W, capital W, and this you can easily manipulate and find the answer. You need not remember this formula. This can be derived in not even a minute. Okay, so you have to focus on simple concepts, using which can solve any problem in GATE. Okay students, the next question is from GATE 2004. The question says the ratio of saturated unit weight to dry unit weight of a soil is 1.25. Okay, the ratio of saturated unit weight to dry unit weight is 1.25. Is the specific gravity of soil solids GS is 2.65. The void ratio of the soil is. So what they have given us is nothing but gamma saturated by gamma D. That is saturated unit weight to dry unit weight, that is given as 1.25. What is gamma saturated? Gamma saturated formula we already know that nothing but gamma T, and these two are gamma T only, but for specific S values. This is for S equals to 1, this is for S equals to 0. So this will be nothing but GS plus E upon 1 plus E into gamma W divided by gamma D is nothing but GS upon 1 plus E, because here S equals to 1, here S equals to 0 into gamma W. That is given as 1.25. Now gamma W will cancel out each other. 1 plus E will cancel out each other. So it will be GS plus E upon GS is equals to 1.25, where GS is given as 2.65 plus E upon 2.65 is equals to 1.25. From here, you can easily find out E value, that is coming out to be 0.663. Okay, very simple problem. For 1 mark, you can easily find out the solution within 30 seconds. You have to minimize your time duration very well in GATE examination so that you can invest these times in tougher questions and lengthier questions. That is how you increase your total number of marks in GATE examination. Okay? Okay students, the next question is from GATE 2000. The question is very simple. Question says a soil sample has a void ratio of 0.5, then its porosity is. Okay, the options given are 50%, 66%, 100% and 33%. Okay, this is a very simple question. You very well know that porosity eta is equals to E upon 1 plus E. If you don't know this formula also, then also you can use your mind. How will you use it? How will you approach it? Is very easy. E is given as 0.5. Okay, so now E is nothing but what? VV upon VS. What do we want is, we want that VV upon total V. That is nothing but porosity. So, our main aim is to find out the value of V by V. So, we have to remove this VS term. How will you remove this? Okay. Now, what I suggest you is like, you first of all take the reciprocal. So, 1 upon 0.5 will be equal to Vs upon Vv. Okay. Why did I do that? You'll understand. Now, if I add 1 on both sides. So, what I'm getting is 0.5 upon 1.5. This will be 1.5 upon 0.5 is equals to Vs plus Vv upon Vv. See here. Now this is nothing but coming out to be V upon Vv. We want what? We want Vv by V. So Vv by V will be equal to 0.5 upon 1.5, that is equals to 0.33, or we can say 33.33%. See here, why did I need the reciprocal? I did the reciprocal because here, if I add 1 directly, I'll get what? V upon Vs. But we will not be able to eliminate the Vs term. So we have to use our simple brains and we can easily calculate the values. Okay? Okay students, the next problem is a borrow pit problem. The question says that a borrow pit has soil of dry density 17 kilonewton per meter cube. Full stop. How many meter cubes of this soil will be required to construct an embankment of 100 meter cube volume with a dry density of 16 kilonewton per meter cube? So what is the basic thing over here is, very important is that whenever you transport one soil to the other, here the soil is transported from here to here. So net weight of solids is constant, or volume of solids for that matter. Because if weight is constant, volume will also be constant, because you just have to multiply by the density won't change. The density of solids won't change. What is changing? The density, the dry density, the total density of the soil, whole soil. Why? Because we just dig this borrow pit and then we take up the soil and we consolidate and compact this whole system and make an embankment of a particular gamma D, that is dry unit weight of 16. Obviously that should be lesser than this because this is an embankment. It should be very stiff so that it can hold long loads and huge loads in the future. Now, So here the gamma D1 is given as this one and gamma D2 is given as this one, then V2 is given as this one. We need to find out the initial volume of the system. How will I find out is very, very important. See, this gamma D1 will be nothing but equal to weight of solids upon volume of 1. Okay, volume before weight of solid upon volume 1. Here, gamma D2 will be equal to weight of solids upon V2. So here if we equate both the WSs, I'll get what? Gamma D1 into V1 is equal to gamma D2 into V2. If I equate the WS, because both the solids from here will be transported to here. So now my gamma D1 is nothing but given as 17 into V1 is nothing but, which we have to calculate, and that will be equal to 16 into 100. So from here V1 is coming out to be 94.12 meter cube, as this is given in meter cube. Very easy problem. That this kind of problem is asked plenty of times, not even in GATE, in ES as well as PSU examinations which are conducted throughout the year, in which you can expect these kind of problems to be there. These are very simple problems, just your concepts need to be there. If there is something new problem also, if your basics are clear, if your concepts are clear, you can manipulate and improvise in the examination and solve that particular question. That will fetch you the rank. Easy questions, every student, each and every student will solve that. But the conceptual questions are there which increase your rank, which you are the one who is solving, others are not. That will give you the rank. Okay students, the next problem is from GATE 2015 set 2. The question says a 588 centimeter cube volume of moist sand weighs 1010 gram. Full stop. If it's dry, weight is 918 gram and G is 2.67. Full stop. Assuming the density of water as 1 gram per cc, the void ratio will be. So here they have given the volume and moist soil weight. So weight in natural is given in gram. So that you have to understand. It is given in gram, not in kilonewtons. They have not multiplied with the G value, or that is the gravity value. Okay. Its dry unit weight is 918. Means that WD is given as 918 grams. So, and also the G value is given as 2.67. That is GS only, 2.67 is given. And also they have given the density of water, that is raw water, is given as 1 gram per cc. Okay. And the initial volume is given as, the volume of the system is 588 cc. Okay. This is a very easy question, very easy for 2 marks, because here everything is given. You you don't have to be confused. Now, I know the formula that gamma T is equals to GS plus SE upon 1 plus E gamma W. See, gamma T is nothing but rho T into G. This can be written as what? Rho T into G. This can be written as what? Rho W into G. So these two will cancel out. Okay, so if you don't multiply that also, but you have to keep both of these in same unit. So here, what is rho T? If I know GS, I don't know the S. I've got the weight of dry soil also. So why not take the gamma D value? So let's take the gamma D value. So if I take gamma D, this SE will be going on. So now this gamma D will be nothing but equal to 918 gram divided by 588 cc. That will be equal to GS is given as 2.67 upon 1 plus E into rho W is given as 1 gram per cc. So this is a very simple equation which I have created over here, and then you just have to find out E, and E will be coming out to be 0.71. This is how we solve these simple questions. Gram per cc should be there on both the sides. Not confused between density and unit weight. Don't have to calculate that. The weight of natural soil was given just for example. So we know GS, we know E. Now, they can ask us to calculate the saturation also in this question. If there was some question, so try going up, just try once to calculate the saturation volume also. How will you calculate? This will be nothing but the net total weight of water you can get, and weight of solid will be nothing but 918. This is nothing but the weight of solids. Subtracting these two will be giving me weight of water. So weight of water divided by weight of solid is nothing but the water content. So you get the water content, you have the GS, you have the E value, you can calculate saturation value very easily. So S value can be calculated also from this question. Why did I use gamma T is equals to GS plus SE? Because I was not knowing S. That would have been lengthier. So why not use this formula? Okay. And here is very easy process to solve these problems. Okay. So you have to choose also what kind of problems you are taking and which procedure you are applying. Just first think for a second. Think for 5 seconds, 10 seconds. Take your time, then proceed. Randomly proceeding in an examination will not help you. It will take your time, it will be time consuming, and it will be also, you will be also losing out with the easy questions which you would have done. Okay? So try to think, invest 10 seconds, 15 seconds at least in the procedure. Just think what is the procedure you will be following. And then only try to move on with the... Okay students, now let's move on to the next problem. That is from GATE 2007. The problem says the water content of a saturated soil and the specific gravity of soil solids are found to be 30% and 2.7 respectively. So stop. Assuming the unit weight of water to be 10 kilonewton per meter cube, the saturated unit weight and the void ratio of soil are. We have to calculate the saturated unit weight and the void ratio. Options are 19.4 and 0.81. Option B is 18.5 and 0.3. Option C is 19.4 and 0.45. Option D is 18.5 and 0.45. It is very easy problem. So let's try to solve this problem by the simple method what we know. So here, what have they given us? They have given us the water content and the specific gravity. So W is given as 30%. And GS is given as 2.7. So, what are they asking is the saturated unit weight and the void ratio. So, they have given gamma W equal to 10 kilonewton per meter cube. Okay. So, when I want to find out the saturated unit weight, gamma saturated, that will be nothing but GS plus SE upon 1 plus W. Okay, into gamma W. 1 plus E into gamma W. So here, this GS is given SE. Now, we know that WGS is equals to SE. So if S equals to 1, so E will be equal to WGS. And W and GS values are given. So gamma saturated will be nothing but equal to, your E value can be easily calculated from here. So E will be equal to 0.3 into 2.7, that is coming out to be 0.81. So we got our E value. Now GS, so here S is equals to 1 for gamma saturated. So GS plus E is 0.81. GS value is already given as 2.7 upon 1 plus 0.81 into 10. Because gamma W is given as 10. So my gamma saturated is coming out to be 19.4 kilonewton per meter cube. Very simple problem, just using the two formulas. These are the manipulations that can be done, and these are the questions which you have to practice. You have to practice more and more problems on this, because you can expect at least 2 questions in the GATE examination on these formulas itself. That is just 4 marks. 4 marks is very huge amount of marks. Okay, so you can expect only 4 marks. There's a weightage of a subject 4 marks, like OCF, like irrigation, like hydrology, surveying. They have their weightages at 4 or 5 marks maximum, and you are getting 4 marks just by solving these 2 formulas. So you have to practice a lot of these 2 problems. Problems based on this, problems based on borrow pit, And we will also now move on with this chapter, and you'll see that you will be getting more and more problems on. Okay students, now let's move on to the next topic, consistency limits. Please write down. Consistency is used to describe the firmness of a soil in terms of descriptions such as soft, medium soft, stiff or hard. So stop. It indicates the relative ease with which the soil can be deformed. So it is nothing but consistency means the firmness in the soil. How firm is the soil? That is what is consistency all about. Okay. Next, write down. Consistency limits are used for the classification of fine-grained soils, especially clays. Okay, you'll find out that why are we using these consistency limits, or it is also called as the Atterberg limits. These are only defined for the clays or fine-grained soils. Okay, so what can we say is that water content influences the consistency of clays. Yes. Why? Because here the consistency limits are dependent on water only. Why? Water only? Because consistency will be firmness, and firmness can be modified by fluctuating the water in the voids of the clay layer. And you very well know that the soil which is most affected by water is none other than clay, because it has negative charge on its plate. I told you before that clays are plate-like structure with negative charges. They attract the positive charges of the hydrogen atom which are present in the water molecule, and therefore water is attached to the plate-like structure in total. Moreover, the clay has large specific surface, therefore lot of water can be spread on the surface, and therefore lots of water are attracted towards the clay particles. That's why you'll get to know that the properties of clay in all depend upon the properties of water in it. So the clay properties will totally depend on the water content, and that's why we are defining these Atterberg or consistency. Okay students, now let's discuss the consistency limits. These are firstly divided into 4 different parts. One is liquid state, plastic state, semi-solid state and solid state. So you will now understand what are these actually. Very easy to understand. Okay, so let's move on and try to understand what are these actually. Okay, let's see from here. Okay, let's suppose our total volume of the system is VD. Our total volume of the system is VD in general state. Here I have solid, water and air. I have solid, water and air most specifically. Now what happens if I keep on adding water to this system? So this air will be filled up with water and the whole system will be now reaching the saturated state. This is called as the saturated state. Now here the whole water content is now complete. The water has taken up the space of the voids, of the total voids is occupied by water. That's why it is in saturated state. For the first time, saturation has been achieved. Now this is the volume. Again we have the total volume will not. So when you add water from this stage to this stage, there won't be any change in the total volume of the soil sample, as the voids are still empty. So that's why from here, so just imagine this is my water content I am plotting and this is the volume which I am plotting. So let's start from here. So let's suppose the water content was initially some W naught, So from W naught, I went on adding water. This was the first stage when I added water. This is the stage. So what happens is the volume is not changing. Volume is constant. And therefore, the final value at this state, the final water content what I achieved is Ws. This is when just for the first time saturation has been achieved. This is called as the shrinkage limit. Shrinkage limit, also called as Ws, denoted by Ws, and that is the point at which for the first time saturation has been achieved. Now what happens if I add water? Now if I add water, obviously the system volume will start increasing and the net volume will now keep on increasing as you add on the water. So the void ratio will also change. Why? Because the net void volume is changing. Therefore, your whole system will be in saturated state. Obviously, the saturation will be there, but most importantly, the volume of the whole system, the volume of the whole voids, the porosity, the void ratio, everything is going to change. So, after some point, as we are discussing mostly clays, what happens is the solid state is now changing because the water is coming on to the system. Obviously, the solidity of the system will change and it will tend towards the semi-solid state. So, from this region, it will be in semi-solid stage. And at one water content, when the soil achieves plasticity. What is plasticity? Plasticity is nothing but deformation without application of load. If a system without activation of load is actually deforming is called as the plastic region. As you have studied in mild steel, the plastic region is nothing but a straight region which the stress is constant but the strain keeps on increasing. So here you will tend towards the plastic state, and that point at which the plastic state has been reached is called as the plastic limit. So Ws is called as the shrinkage limit, and Wp is called as the plastic limit. And therefore Wl, finally, after the plastic state, the system will be tending towards the whole liquid state. It will flow like anything, and therefore you need not put even a pin drop of your stress. So stress is never there. It is flowing like a liquid. That's why the whole soil system becomes a liquid. The soil grains are dissolved in some manner in the whole water. It will flow. Therefore, the system will be in liquid state, and where the liquid state starts is called as the liquid limit. See, what are these actually? Shrinkage limit, plastic limit, and WL these are the property of one soil. This is a general term that this can be achieved if we apply this amount of water. If we add this amount of water, this limit can be achieved. Now, what happens is the soil, the clay actually here which we are discussing, is capable of taking up a lot of water. It can take a lot of water without reaching the plastic state because Wp is huge and WL is also huge. There is a large difference between Wp and Ws and WL and Wp. Therefore, the system is tending in different states, and that's why we are defining different limits, because it can achieve those limits. There's a wide range between them. There's a huge range in this. Why? Because it is able to take up more water and then still remain in solid state. If I try to plot the graph of a sand, this is obviously for clay. So obviously from starting to initial stage, when the whole voids will be filled, it will be coming to shrinkage limit here like this. Now after that, when the volume increases, what will you find that after some point of time only, it will be tending towards the plastic state, and then after small point also, this will basically coincide each other, and Wp and Wl will coincide each other because there is not lot of water which it can take. What happens is we put some water, starting only it will try to flow, it will behave as a liquid because it is not able to take water inside it and remain solid, remain semi-solid, remain plastic. It is not able to do that. What is it doing? It is just trying to take water and it starts flowing straight away. That's why there is not a lot of difference between WL and WP, and that is why we define a term called as the plastic limit, termed as IP, which is called as the plastic limit, and that is WL minus WP. Okay, this is very important term, that is our IP, and you can very well say that IP for sand will be equal to 0 because there is no difference. Therefore, sand has plastic limit as 0. Sorry, the plasticity index. This is called as the plastic limit. We have already studied. This is called as the plasticity index. Okay, the plasticity index is WL minus WP. So IP for sand will be nothing but 0 because there is no difference between the WL and WP. Please note down this. This is very important. Okay, students. Now let's write down the definition of shrinkage limit WS. Please write down. Write down. It is the boundary moisture content between solid and semi-solid state. It is the boundary moisture content between solid and semi-solid state. Stop. It is the moisture content at which the soil is just saturated. The soil is just saturated. That is minimum moisture content. That is minimum moisture content at which the soil could be saturated. As I told you. Full stop. When the water content is reduced below, shrinkage limit water content. All these are what? Water content only. What are these? Shrinkage limit, plastic limit, liquid limit, these are water content. So we also say WS as shrinkage limit water content, WP as plastic limit water content, WL as liquid limit water content. Okay. So what we are writing? We were writing when the water content is reduced below shrinkage limit water content, volume of soil does not change, but the color of soil sample begins to change. This is a very important phenomenon that you have to understand, that this is how the shrinkage limit is defined. Next, write down plastic limit, WP. So plastic limit is the boundary moisture content. Plastic limit is the boundary moisture content between plastic and semi-solid state. Next, write down liquid limit. Liquid limit is the moisture content. Between plastic state and liquid. Okay, students. Now let's write down a few formulas. First is the consistency limit, IC. IC is nothing but the consistency. Okay, that is equals to WL minus W upon WL minus WP. It's nothing but IP only, and this is the liquid limit. This is the liquid limit minus plastic limit upon the minus W. What is W? W and WP you already know. Small w is natural. What is the current moisture? Then you have liquidity index, IL. That is nothing but W minus WP upon WL minus WP. This is called as the liquidity index. Okay, here again W is the natural moisture content. So can WLIL be less than 1? Yes, it can be less than 1. Sorry, less than 0. Yes, when the W will be lesser than WP, obviously this will be negative. Now what is very important over here is that IC plus IL, please note down this formula, this is very, very important. Next, we also have relative density. The next formula is for relative density is represented by dr, and dr is nothing but equal to Emax minus E upon Emax minus Emin. Okay, it is just giving us the density, how densely the system is packed. Here Emax is maximum, E is the natural or the current. One more thing which we define is the activity, AC. AC is nothing but called as the activity of a soil. That is AC is equals to IP upon percentage of clay particles. Okay, IP you already know is nothing but WL minus W. So these are the important things which we have to discuss. This is very, very important, and a lot of questions are asked from these formulas in previous years GATE problems and PSU examinations as well. So we'll solve some problems based on consistency limits, Adaberg limits, and these formulas. Okay students, now let's discuss the next problem, that is from GATE 2014, set 1. That is set 1, GATE 2014. Okay, the question is, a given cohesionless soil has Emax equal to 0.85 and Emin equals to 0.5. Okay, in the field, the soil is compacted to a mass density of 1800 kg per meter cube at a water content of 8%. Now, they given us the gamma T value. The mass density is 1800 kg per meter cube. It's not in kilonewton per meter cube, it is in kg per meter cube. So you have to be aware of the units as well. Okay. Next is, take the mass density of water as 1000 kg per meter cube and GS value as 2.7. Then they are asking me the relative density. Okay. So they have given us Emax. Emax is given as, so also they have given us the Rho T. Rho T is nothing but given as 1800 kg per meter cube, and Rho W is given as 1000 kg per meter cube. Water content small w is given as 10%, 8%. It is given as 8%. And also they have given us the GS value. They have given us the GS value. So GS value is given as 2.67. 2.7. GS is given as 2. First of all, I want to find out the relative density dr. So dr is nothing but equal to Emax minus E upon Emax minus Emin. Okay. We know Emax, we know Emax, we know Emin. We need to find out E value. So E can be found out with using these two terms. We know that Rho T is equals to GS plus SE upon 1 plus E gamma W. Now GS is given as, so Rho T is also given, that is given as 1800 kg per meter cube. I told you you can convert it into Rho T as well because G can be cancelled from both sides. This will be 1800 kg per meter cube is equals to 2.7 plus SE I will replace by WGS because W and GS are known. So 2.7 into 0.08. okay, upon 1 plus E into 1000 kg per meter cube. So only one is the unknown, that is E, and that is coming as 0.62. So I got my E value as 0.62, and therefore my relative density dr. So they are asking in percentage. They are asking the relative density in percentage because the options are 56, 60, 62.87 and 65.71. So our dr will be equal to 0.85 minus 0.62, and this you should multiply by 100 to get in percentage, divided by the correct option is option D, that is 65.71%, which is very easy. You can calculate it, very easy question. So this is for 1 mark, so it is lengthy, so you should maintain your speed in order to solve these. Okay, next problem is from GATE 1999. Problem says the principle involved in the relationship between submerged unit weight and saturated unit weight of a soil is based on option A, equilibrium of floating bodies, option B, Archimedes principle, option C, Stokes law, option D, Darcy's law. So you very well know that the principle of submerged unit weight is nothing but Archimedes principle. Why? Because I told you, if a soil is assumed to be of volume V, if it will supply, or it will be giving out gamma saturated into V downwards, it is the mg, because it is fully saturated, so it will be mass into density into volume will give you mass, into G will be giving you gamma. So also it will displace some amount of water, and that can be collected in any bucket or any vessel, and this will be the water which will be contained of volume V only, which is this one. So both the volumes will be same. So the buoyant force according to Archimedes principle is nothing but equal to the weight of water displaced. Weight is nothing but force. So obviously you are calculating force. So they're just saying that that will be equal to magnitude of that weight. That is equal to what? What will be the magnitude of this force? This will be gamma W into V. So that is why the principle involved is Archimedes principle. So the correct answer is option B, that is R. Okay students, next question is from GATE 2016. Set 1. Very easy problem for 2 marks. See how easy the question is. Okay, the question is saying that the porosity N or eta and the degree of saturation S of a soil sample are 0.7 and 40% respectively. In a 100 meter cube volume of soil, the volume expressed in meter cube of air. They are asking us the volume of air in the system. So porosity is given as what? The porosity, that is eta value, is given as 0.7. What? The saturation is given as 40%. S is equals to 0.4. Talking in decimal. And the V volume, the total volume of the system is 100 meter cube. So they are asking the volume of air. So how will I find out is very easy, because I know that eta is equals to VV upon V. That is given as 0.7. So V is also given as 100. So implies VV will be equal to 0.7 into 100. That is coming as 70 meter cubes. Okay. And saturation S is given as 0.4, and that is nothing but equal to, saturation is nothing but volume of water upon volume of voids. That is given as what? 0.4. So if I want to find out the volume of water, that will be nothing but 0.4 into VV, that is nothing but 0.4 into VV is, now we very well know that it is 70. This is coming out to be 28 meter cubes. So now VV is equals to 28 meter, VW is equals to 28 meter cube, VV is equals to 70. We very well know that VV is equals to VW plus VAR. Air plus water is nothing but the void composition. So our VA will be equal to VV minus VW. So VV is nothing but 70 minus 28, that is coming out to be 42 meter cube. You have to fill in the blanks as 42 meter cube. Such an easy problem for 2 marks. I hardly think that you can solve this question in within 1 minute very easily. Just have to keep your calculations very correct. Steady head is what is the need of the hour. You have to have steady head and brain. If you go in tandem, everything will be done. Okay? So just focus on the questions. Questions are very simple. Just have to focus on the process and things will be done. Okay students, now let's look at the next problem of GATE 2015. Set 1. Question says, a fine-grained soil has 60% by weight silt content. Okay? Very important. Full stop. The soil behaves as semi-solid when the water content is between 15% to 28%. Okay? Then, the soil behaves fluid-like when the water content is more than 40%. Okay? When the water content is more than 40%, full stop, the activity of the soil is. I want to calculate the activity. The options given are 3.33, 0.30, 0.42 and 0.2. Okay, so basically this is a fine-grained soil. So fine-grained soil will have majority of fine-grained soils. Obviously, yes, there will be some coarse-grained soils also mixed, but it is saying that majority is fine-grained soils. 60% is silt. So 40% will be what? 60% is silt. So 40% will be clay. Isn't it? Most importantly, they have also mentioned that the soil behaves as semi-solid when the water content is between 15% to 28%. This is 15% and this is 28%. This is because it is semi-solid. Next, the soil behaves fluid-like when the water content is more than 40%. So when the water content is more than 40%, it behaves like a fluid or a liquid. So that is what they have given. So that means this is my shrinkage limit, this is my plastic limit, and this is my liquid limit. So I know shrinkage, plastic and liquid limit. So I want to calculate the activity of the soil. So the activity of soil will be very, very important and very, very easy to calculate. We know that activity is nothing but AC is equals to is IP upon percentage of clay. So both you can keep in percentage. IP will be nothing but WL minus WP. That will be equal to 12% divided by, what is the percentage of clay particles? That is 40%. That will be nothing but 40%. So this is how we calculate it. This will be nothing but 12 by 40 will be equal to 3 by 10 or equal to 0. Okay students, now let's look at the next problem. The problem says the Atterberg limits of clay are 38%, 27% and 24.5%. These are the Atterberg limits. WL will be maximum, then WP, then WS, most probably. Yes. Now, the natural water content they have given as 30%. The natural moisture content is 30%. They are asking the clay is in which state? Very, very easy, because 30% will lie somewhat here. So this will be my 30% moisture content and the clay will be in plastic region. That is very, very easy to identify. This was a very easy problem from GATE 1994. The next class will discuss more questions, concept based, and we'll try to study few other unit weight determination and moisture content determination